Okay, in this particular exercise, we are going to determine how many grams of water can be formed from 7.5 times 10 to the 23rd atoms, molecules of hydrogen using the equation H2 plus O2 goes to form water. The very first thing we need to do is we need to balance this equation, and to balance this equation it's going to require 2 hydrogen molecules and 2 water molecules. Now, next we're going to identify what we're starting with. We are starting with 7.5 times 10 to the 23rd hydrogen molecules. We need to identify what we want. We want the number of grams of water. So now we're going to break this apart and determine what we need to work with. The very first thing I notice is I have hydrogen and I have water. They are different molecules, so we will be using a mole-to-mole ratio from the balanced chemical equation in order to convert between hydrogen and water. According to the balanced chemical equation, for 2 moles of hydrogen that react, you get 2 moles of water. The next thing I see is I have molecules. Anytime I have molecules, that means I'm going to need to be using Avogadro's number. So there are 6.022 times 10 to the 23rd hydrogen molecules per 1 mole of hydrogen, or I should say equals to 1 mole of hydrogen. The last thing I noticed is I want grams. Anytime I want grams, I will be using the molar mass. The molar mass of water is 18.01 grams of water is equal to 1 mole of water. Having looked at everything and trying to discern what's going on, strictly from what we're starting with to where we want to go, we are now ready to start this conversion, and hopefully we have all of our conversion units that we need. So let's begin with what we were given. We were given 7.5 times 10 to the 23rd hydrogen molecules. Our very first conversion factor is going to require molecules, so we will be using our Avogadro's number, which is 6.022 times 10 to the 23rd hydrogen molecules is equal to 1 mole of hydrogen. The molecules were placed in the denominator so that the unit and the substance would cancel out, leaving us moles of hydrogen. Now that we're in moles of hydrogen, we can convert from moles of hydrogen to moles of water using our mole-to-mole ratio. According to the mole-to-mole ratio, 2 moles of hydrogen react to form 2 moles of water. The mole of hydrogen was placed in the denominator so that the unit and the substance would cancel out, leaving us moles of water. But we want grams of water, so we need to use our molar mass of water. The 1 mole of water will go into the denominator, while the 18.01 grams of water is placed in the numerator. The mole of water was placed in the denominator so that the unit and the substance would cancel out, leaving us grams of water, which is what we wanted to solve for. So now we're ready to begin this calculation. So we have 7.5 times 10 to the 23rd divided by 6.022 times 10 to the 23rd times 2 divided by 2 times 18.01. And when we key this into the calculator, you get 22.4303 grams of water. Now we need to determine our number of significant digits. The 7.5 times 10 to the 23rd has 2 significant digits because it has 2 digits in the mantissa of the scientific notation. The 1 mole of hydrogen from Avogadro's number is an exact quantity, so it has an unlimited number of significant digits. The 6.022 has 4 significant digits. Mole-to-mole ratios are exact quantities, so they have an unlimited number of significant digits. The 18.01 has 4 significant digits, and the 1 mole in a molar mass is an exact quantity with an unlimited number of significant digits. So you have 2 significant digits times an exact number of significant digits divided by 4 significant digits times an exact number divided by an exact number times 4 divided by an exact number. Multiplication and division says that the answer will have the same number of significant digits as the measurement with the fewest. The measurement with the fewest was 2, so our Answer can only have two significant digits, so we would record our answer as 22 grams of water.